Hi everyone, welcome to Differential Calculus. Today we explore lesson 4.2, the mean value theorem. Number one, the mean value theorem. MVT, if f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there is at least one number c in the open interval a to b such that f prime c equal to fb minus fa over b minus a. F prime c is slope of tangent line at c. The quotient of fb minus fa over b minus a is slope of the secant line. Between the 2 points A, FA, and B, FB. Slope of the tangent line can also be interpreted as the instantaneous rate of change. Slope of the secant line we can interpret at the average rate of change. Let's take a look at a curve that is continuous on the closed interval a to b. So we can always get a secant line through the two endpoints. Yay. Let's take a look at the slope of the secant line. Notice that there's the tangent line right here. And we also have another tangent line right here that have the same slope as the slope of the secant line. Tangent line 1 at x equals c, and the tangent line 2 at x equals d. Yeah, this illustrates the mean value theorem. Let's take a look at the application of mean value theorem. Number 2, applications of MVT. First example, let fx equal to root x, find a number c in the open interval 0 to 9, guaranteed by the mean value theorem. We know that the mean value theorem tells us that there's a c such that f prime c equal to f9 minus f0 over 9 minus 0. And because fx equal to root x, f prime x is 1 over 2 root x. So do the substitution. I mean, f prime c is 1 over 2 root c. So 1 over 2 root c equal to f of 9 is root 9, f of 0 is root of 0 over 9. 1 over 2 root c equal to 3 over 9. So we have 1 over 2 root c equal 1 over 3 and 3 equal to root c. So root c is 3 over 2, which means that c is 3/2 square. And therefore, we have 9/4. Let's take a look at the graph here. So this is the square root function, the sketch. F of 0 is 0. F of 9 is 3. So there's another point. Yay. Here come the second line. So I found a tangent line. Yay. And this point right here is at x equal to 9/4. Awesome. Let's take a look at another example. A rock falls from a cliff 256 feet above the ground. Its position in feet after t seconds is modeled by s of t is equal to -16t squared plus 256. Find a time when the instantaneous velocity of the rock equal to its average velocity from the time it stopped falling until the impact time. So here come a little graph of what is going on. P and this S of t. Clip 256 feet. And when the rock start falling down, it looked like this. Ta-da! Impact time. Starting time and impact time. Okay, so in order to figure out the impact time, we just set the position function equal to 0. Set st equal to 0 and solve for t. -16 t squared plus 256 equal to 0. T squared is -256 over -16. So t squared is 16, and therefore t is 4. By the mean value theorem, there is a c in the interval from 0 to 4, such that s prime c equal s4 minus s of 0 over 4 minus 0. We can figure out the s prime c. We have s of t. So now s prime t is -32 t, and therefore s prime c is -32 c equal s of 4. That would be the position when the rock impact the ground, which is 0. S of 0 is the initial position, that is the height of the cliff, 256 over 4. So -32 c equal to -64, and therefore c is -64 divided by 32, which is 2. It's a different example. A function is increasing on an open interval I if fx sub 2 is greater than fx sub 1 whenever x sub 2 is greater than x sub 1 in I. Show that f prime x greater than 0 for all points in I, then fx is increasing on I. let x1 and x2 be in I, and x2 greater than x1 by the mean value theorem. There is a number c in the interval x1 to x2 such that f prime c equal fx2 minus fx1 over x2 minus x1. Now we need to show that fx2 is greater than fx1. So we know fx2 minus fx1 equal f prime c multiplied to x2 minus x1. Well, f prime c is more than 0 from the assumption. x2 minus x1 is more than 0 because x2 is more than x1. So fx2 minus fx1 is greater than 0. And from there, we see that fx2 greater than fx1, which show that fx is increasing on I. Wow, that is one of the coolest use of the mean value theorem. We can also use the mean value theorem to prove trig inequality. Let's take a look at an example. Let fx equal psi x show that psi x less than x for all x in the interval 0 to 2 pi. Let x be in the interval 0 to 2 pi. Then 0 less than x less than 2 pi. So by the mean value theorem, there is a c in the interval 0 to x such that f prime c equal to fx minus f of 0 over x minus 0. Derivative of psi is cosine, so we have cosine of c equal to fx is psi x, f of 0 is psi of 0 over x cosine c equal psi x over x. And we know that cosine c is less than 1 for all x in the interval from 0 to 2 pi. What this means is psi x over x has to be less than 1. And so psi x less than x for all x in the interval 0 to 2 pi. That is it. We just proved a trig identity. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.